Hello there. Welcome to lecture 4. So today we look at selection sort. There are a lot of sorting techniques like selection, bubble, insertion, merge, heap, quick, bucket, radix. Each of them have their own advantages and disadvantages. In all the lecture series later, we will cover all these sorting techniques. So in this lecture I have chosen the selection sort technique. So we can sort either in ascending or descending order. We will sort any given number set. Now the selection sort algorithm sorts an array by repeatedly finding the minimum element, that is considering the ascending order, from the unsorted part and putting it at the beginning. So what does that actually mean? Suppose if I have a number set called 1, 1, 3, 2, 5, 4. If this is the original set, so in the first pass what I do is I will find the minimum element out of this array and I will put it in the beginning. Now in this case what happens is the minimum number is already there, okay, as 1. So next what I do is I take the array like this and find the minimum element in this array and exchange with this. Okay, so my next, in the second pass what I get is I get 1, 2, right? Now the issue comes is with which location should I interchange? So if you now look at, you take 3, is 3 less than 2? No. Okay, so then if 3 is not less than 2, you interchange, right? Now the 2 remains here, the 2 is minimum again check, is 2 less than 5? Okay, yes, is 2 less than 4? So after that pass you will get an array like this, hopefully an array like this. Okay, so in my third pass, since I have already completed 2 passes, this is 1 and 2 the sorted array, I will compare, is 3 less than 5? Fine. Is 3 less than 4? Fine. So it will retain its position. The remaining is 5 and 4. So my fourth pass, 1, 2, 3, okay. Now it looks at my 5, compares it with 4. So now this is my minimum location, so I will interchange. I will make it as 4 and 5. I still don't know whether the array is sorted or not, so I will go to my fifth pass, correct, and I'll again check if the last number is already sorted, so there is nothing to interchange. So in the fifth pass I should get the sorted array. Okay, so if you look at, in the first pass I compared with 5 elements, the next pass I compared with the remaining 4 elements, then the remaining 5 elements, then I compared with everything. Okay, so if the array is already sorted, for example, I still have to check. Okay, I still have to do n number of passes, right? So in the algorithms chapter, they will actually talk about time complexity and O notations and theta notations and omega notations, which we will not worry about it now. Now this I can actually implement the way I want. So what we will do is we will just implement this using implement selection sort using arrays, pointers, recursion and function. We'll try and put these restrictions on that. Okay, so let us take step by step. First I want to implement using selection sort using array. So first let me look at the array. So I do the hash include stdio.h. Okay, first I'll create an array. I'll say an array A of, I'll give a maximum of 50. Okay, that's the array that I have created. Then I'll also create n, which indicates the number of elements. So this is an array of 50 elements. and this is for the number of elements. Alright, so we'll write a function first main and accept the array. Okay, for that what I will do is I'll say printf enter the number of elements in the array. So I will scanf %d and of n. Okay, now for I is equal to 0, I remaining less than n, I will read the elements. Okay. For this I will also have to create int I, okay, for use as an index. Alright, now what I will do here is I will say before this enter the elements. So here I will say printf, I let it look like I'm accepting in the form of an array. I'll say a of I, which is %d, okay, is equal to my I. Here I'll do the scanf /n or %d and of a of I. So I'm reading element by element. So we will use the same thing to display the array. Okay. The elements, the n elements of the given array are, this is my n, okay, I will simply put here %d and this is my a of I. So this is the first step. This is how I have to develop the code. Okay, so I will say selection sort, okay, dot c, we'll say yes. Okay, so this logic is to read an array and this logic is to print the array. N elements. Okay, so we'll do stage wise. We'll just see if this code is going to work. Okay, then we'll move forward. So I have saved it. Let us go and compile this. Okay, so we'll say gcc -o op sort.c. Okay, so we have an error there. Okay, so since it is a block, one is, we'll put a semicolon here. In this case we don't need it, right? So I will save this code, then let me execute this code. Okay, so we have few more errors here. Let's I have to give a bracket here. Okay. Nice to get errors. Alright, so enter the elements of the array. So we'll say we will 5. Now a of I is say 1, 3, 2, 5, 4. So 1, 3, 2, 5, 4. So at least our array elements are perfect now. Okay. So now next is I have to just call a function called selection sort. I'll say cell sort. For that function, I'll simply send the array, which is my array. Alright. So I have to write a function called selection sort. Now what am I supposed to do? I am supposed to use, I have used arrays now, I have to use pointers. And then recursion, okay, a recursive function. Instead of saying recursion, I'll say recursive function. So for that, let me first write a function. I'll say int cell sort. I will have a pointer called p, which I will refer it to the array A. Okay. Now I have to write a prototype. To write a prototype, the simple technique is copy this on top of it. Even if we have star p, it doesn't matter, but we'll just leave it as it is, int star. So this is my prototype. So here what I have done now is I am supposed to sort using the sorting technique. So how am I going to do this sorting technique is same as we sorted. So first thing what I do is, first thing I will point to the first element. Okay, so that is my first element. So I'll have a pointer called temp. Okay, which will be p, which means, let me take the array itself, 1 1 3 2 5 4. This is my array. Okay, my array now is 1 1 3 2 5 and 4. Okay, so first what I am doing is, when I call a, my p is referring to 1, my temp is referring to p, which is referring to 1. So I am actually referring to the first element. Alright, so then what I will do is I will take a number called small, and I'll assume that my first number is the smallest number. Okay, that's how I assume. Then one more thing I have to do is, in this case I know the length of the array, but what I will do is I will, in the end of the array, means my value of I is n, I will insert a hexadecimal value called FFFF. That's called that for sentinel value. So I'll say for imposing sentinel value. Alright, so 0xFF means that my last one number is 0xFFFF. Alright. Okay, so now what I will do is so which means I am now referring to this. This is the smallest number, so I also have int star. This is my star p, and that int this gets small. So what I'll do now first is I will traverse through the array. What will the array traverse through the array will do? I'll say as long as my star p is not equal to 0xFFFF, I can traverse. So first let us traverse and see what will happen. So this is, we are developing the code stage wise. The traverse elements are, okay, we'll just traverse. So what will we do? We will say printf %d space comma, we will say star p. Okay, so, and then we will increment the pointer by 1, p plus plus. We just want to see whether this actually traverses. So since I have called this function cell sort A, so it should actually display 1 3 2 5 4. Let us see if that works. Looks to be fine. So I will say I want 5 elements, 1 3 2 5 4. Okay, so I am getting the array, so means I am able to traverse the array. If you see here, 1 3 2 5 4. Alright, so not a problem at all. Okay, so now, which means I am able to get the first element. I mean, when I say star p, I am able to get the first element. Here what I will do is I'll say if my small is less than star p, it's fine. I mean, even if it is same, I can just traverse. Then I'll create a variable called exchange, which is equal to nothing. Okay, exchange. I will say exchange. I have to exchange the value, because if small is greater than star p, which means there is the next number is greater than smaller than smallest, so that should be the smallest number. So for that I'll exchange. I'll say my exchange now will be equal to star p, whatever is the value of star p. Then my star p will be equal to small, and my small will be equal to exchange. I hope you understood this. I'm going to put this in exchange. So exchange will have star p, then the smallest value I'll put it in star p, and this is my small equal to exchange. So I get the smallest element now. Alright, so I'm traversing through. Okay, so when I'm doing this, let me see, once I traverse, and after that I am incrementing. If small is less than star p, I simply increment it. So after this loop I should get the smallest element. That's what it says. Printf, the smallest element is percentage d star p, or small. Alright, okay, let us see what will happen. Okay, so let us see how are we able to get the smallest element. Right, so we'll save this, and then compile this. P 5 1 3 2 5 4, the smallest element is 1. Right, so we are able to pick up the smallest element, which I will now exchange, isn't it? So I've got the smallest element after this while loop, isn't it? So only for the first pass. So first what I will do is, first things first, I had, because the pointer has already traversed, but the temp value had been saved, means it is pointing to the first element. I'll say my star temp is equal to yes, which is nothing but small. Alright, now my smallest element is something called small. Right, so what we will do is, we will also have a function to display the array. So this we will take out and put it in the function. We'll create a display function. This is only to display, void display. There also we'll take int star, say k. Okay, we will say while k is not equal to 0xFFFF. Okay, print the array. Printf slash n a of percentage d is equal to percentage d. Right, we will say star of k. Alright, we can have one temporary variable called int I, okay, which is initialized to 0, and I will print here I plus plus. This is only a display function. Alright, okay, So we have a display function. I have to create a prototype of a display function. I'll go on top and put a display function. Now display function we are only using to find the different passes, right? So this will be my instar. This is my display function. Okay, my display function. Alright. So what I will do is, so in this case I will call the display function just to display the array. How do I call the display function? I'll just say display. Okay, so what will I display now? I'll send the array A, because array is a global variable, and let me see how this actually works. I can put here the printf the array status after pass %d, which is equal to, I'll have a pass. Okay, so this will be my first pass, correct? Alright, so my pass has to remember the previous passes, so I'll name it as static int pass is equal to 0. Okay, the moment it enters, it is my first pass. I can say the first pass is over. I'll say pass plus plus. Let us see if we are able to get some visualization of this. So I will have GCC. Okay, so we have some problem there. Not ignore the pointers, warning with respect to pointer. Okay, I think I should have given here a display. So it says I am comparing pointers. So while star k, that's what it is. So I will just GCC minus O OP. So our file name is ssort. So let me just give 3 elements for a change. 1, 3, 2. Okay, so now it is going in an infinite loop. That is because of our display. Alright, so what we will do is, we have not incremented k, that's the problem. So we'll increment k. Okay, the display. So we'll enter 3 elements, 1, 3, 2. Okay, so it is showing some junk. That is because we wouldn't have given the value there. So we will give I and star k. Okay, so I have this, so 3, 1, 3, 2. So 1, 3, 2. So we are able to get the, after the first pass, the array is 1, 3, 2. But our problem there is, how do I go to the second pass, isn't it? For that I do the recursion. So I will call the select sort, this function again, the cell sort. Here what I will do is, I'll increment my temp now, plus plus. It has gone to the second point here. Now I know it's already the first element is done. Now I have to give the second, from here to here I am supposed to do that. So for that what I'll do is, I'll call the selection sort function, and there I will pass temp. Okay, but here what may happen is, if my star temp is not equal to FFFF, because I have not reached, then only I'll call the recursive function. Okay, alright, else I'll return 0. It's successful exit. Okay, which means go to the next pass. Okay, normal exit. Alright, so let us see if anything is going to work this way. So we will just do the GCC. Alright, we'll do the OP. So we'll say 3 elements, 1, 3, 2. Alright, now if you see, it is beautifully working. In the first pass the array was 1, 3, 2. In the second pass the array was 1, 2, 3. Third pass it is 1, 2, 3, because in 1, 2, 3 it doesn't know whether the last element is the smallest. So this is why you actually do the pass, right? So let us take more elements now, right? Let us take more elements and see if this is going to work fine with more elements. So let me just take our earlier example. We give 5 elements, 1, 3, 2, 5 and 4. See, isn't it? So in the first pass, luckily we had 1, 3, 5, 4, 2. Okay, so we had in every pass the smallest element got, right? So if you see, it looks to be already sorted, but here it sees 1, 2, 3, 5, 4. It will do 1, 2, 3, 5, 4 in pass 3. In pass 4 it will do 1, 2, 3, 5, 4, 5. Again it will check for one more pass, so which is 1, 2, 3, 4, 5. Okay, that is because I am supposed to go to the till the last element. All right, so let us give the best case and see. Okay, what is the best case? I give the sorted array itself. So 5, 1, 2, 3, 4, 5. So even then it does 5 passes, because it doesn't know whether the array is sorted or not, isn't it? Okay, now next we will give the worst case. What is the worst case? Because if I am sorting in ascending order, I will give the descending order. Even then it needs 5, isn't it? Now if you see, it did we gave 5, 4, 3 to 1. So 5 got the 5, 4, 3 to 1. So 1 came above, then the 5, 4, 3 to remain here. Then again I put 2 from here, then it put 5, 4, 3, then it did 1, 2, 3, 4, 5. What is the average case? The average case we have already seen. It's 5. The average case is 1, 3, 2, 5, 4. So it also does the same thing. So I hope that you were able to figure out the logic. We satisfied everything. We had recursive arrays, we had pointers to traverse, we also had a recursive function here, isn't it? So we had a recursive function. The only thing you have to understand is, if my sentinel value, right, is not there, then I have to use the value of n. So what I did was, we will just use the sentinel value from all our programs just to put it is within the array, so that I know that's the end of the array. But if you overwrite on that, that's a problem. Now, so sometimes people say that, sir, I can as well use this terminator, but the termination operator is equal to actually 0. So if you put a 0 element somewhere in the array will the scanning will stop there. Okay. Hope that you understood this logic. Please try out, go step by step. Just for our heart's content, we'll give a large array now. Okay, we'll give array of 10 elements. I'll just give some case. Alright, so even then it is able to sort. So my -9 to 44. So it needed 10 passes, correct? So I had 10 elements, 10 passes, isn't it? Okay, so hope that you understood this logic. Subsequent sorting techniques in the other lectures. Thank you very much.